Howdy, long time no see. Yeah, I was studying a lot last year, and I didn't have that much time for personal projects, but I completed the course recently, so I sat down and I did me some coding. Hopefully you can tell from the title, things went pretty well, until they didn't. So, let's start with Huzzah. Unfortunately, I had a few months away from my code, so I was a bit terrified. I assumed that once I looked back into it, it would be not only held together with gum and tape, but once I ripped it open and peered inside, that I'd realise its components were made up of cutlery and sheep organs. How did it ever work? Thankfully, once I actually started looking into my old code, I realised I write in a pretty modular fashion. Most of it made sense. There are a few quirks that if I did a rewrite, I'd fix, but I figured they're okay for now. Thankfully, last time I touched the code, I set up a big old list of things to do. So I just started ticking things off. Do you remember those doors I talked about last time? Well, now they open and close. Look at them go. And I finally put decals in. For those who don't know, a decal is a small texture projected onto a surface, a bit like a sticker. It's usually used in games for things like bullet holes and blood splatter, which is exactly what I'm using it for in this game. The reason I'm so pleased with my implementation of decals is that I didn't look it up. I just sort of guessed, drew some little scribbles, and then broke it down to little parts and tried to make it myself, which is half the fun of programming, I think. I knew that I wanted the decals to wrap around the surface and not just be a flat plane sitting on the surface. Some games do that, but I really wanted just to get the basic wrapping to occur. The idea was pretty simple. First, find the collision. From there, locate the surface. Then, get the normal of the surface to build a matrix. Then, apply the inverse of the matrix to the surface, which makes that surface almost two-dimensional. It's now lying flat. This really simplifies the mathematics, so I was quite pleased with that. Now, there's the surface and the quad. I locate the intersections between both and what points exist within each other. Knowing that both shapes are convex, I can assume the resulting shape will also be convex, which also really simplifies things. Now all I have to do is sort the points clockwise from the center of the new shape, and I have my decal. Now, after this, I was a bit stuck, because I didn't know how to get the new texture coordinates. In fact, I didn't even have the vocabulary for it. So, I asked some AIs. It turns out that I could find these coordinates through bilinear interpolation, and ChatGPT gave me code that worked really well. I actually wasn't expecting that. I only had to correct one line, and it worked. So, that was good enough for me. I'm pretty sure there's probably a smarter and more efficient way of doing it, but as far as I'm concerned, I've got myself a decal system, so I'm pretty happy with that for now. After that, I decided to add some simple dynamic lighting. When I say simple, I mean simple. When something emits a light, a function is called, which runs through the scene's quad tree and locates the quad, which intersects with the bounding box, a square, of the light, and then adds that light to a fixed list of lights within the quad. These lights have a colour and a decay rate. It's nothing like realistic lighting. It doesn't have a fall-off value. It's pretty chunky. But I don't know, it sort of suits the project. I'm pretty happy with it. It's nothing amazing. I like it. Up to this point, the project had no sound. I hadn't incorporated a single line of code relating to sound. So I needed to start doing that. Since I was using SDL2 and SDL image, it would have made sense for me just to use SDL mixer, but for anyone who's used it, you probably know it's a bit lacking. It can't stream more than one piece of audio at once. The reason you might want to stream multiple pieces of audio would be dynamic music or for dialogue, which this project actually doesn't use. But I figured it was a good chance to, give it a go, see if I could write the code. I ended up using libVorbis to load in OGG files, and then fed them into a cyclic audio buffer that I wrote for SDL2. It wasn't that complicated, so that was fun, but my current sound system's pretty simple. It can load in some mono sounds, which emitters can, project, giving sort of a fake 3D sound, and stream more than one piece of audio for music, though in this game it's probably going to be using two at most, like fading in and out from one track to another. I think that I'll be putting more time into the audio system later on, and I'm interested in how it might compile for Emscriptum? I don't know, the web browser thingy. And I'd be interested in how it compiles for Android. libVorbis seems not too complicated to port, but we'll see how it goes. So I sort of have a sound system. It's pretty neat. Good for me. Somewhat finalizing things, I ended up writing some code for the HUD elements. It contains a finite state machine for the weapons drawn on screen. I can draw 2D elements over the top of the 3D engine. It's nothing really interesting, but yeah, it worked. Pretty happy with that. You can see the thing going pew pew now, and you can see how much you're dying. That's neat. Yeah. Well, there I was, sitting there going, this is going pretty good. This programming thing's easy. Everyone should be doing it. But while testing, I noticed that the CPU usage was very high. And that's actually not that surprising, really. The engine is simple. It was always meant to be simple. The game loop is not complicated, especially compared to modern games. So while it's running, it will gladly just keep rendering hundreds of frames per second, which is pretty neat. But I was programming a game that was meant to be a retro game, and I was coding it from the ground up. There shouldn't be that much overhead. I'm not using a big bulky engine for it. It's all pretty simple. So I wanted that CPU usage down. The solution was easy. I was currently running it uncapped, so I decided to cap the frame rate. So I capped the frame rate, and then realised the lower the frame rate, the more busted the game is. It turns out the collision system was failing almost constantly. This left me pretty perplexed, and I was actually sitting around wondering, can I actually code? What's going on? And the other obvious question was, why was it working at a high frame rate? Why did it fall apart the second I lowered the frame rate? To understand what's going on, we have to look at how my engine handled collisions. It first starts with the assumption that an entity is inside the map and not embedded in any surface. If this holds true, we can get the velocity of the object and cast it against the walls that are close enough to be considered for checking. The wall location is modified by the ellipsoid radius, so it's pushed forward a bit. If there is no collision based off the ray check, cool. We can move the object. There's no collision, it's all good. But if there is a collision, we have to locate the collision distance, the location of the collision, and the normal of the wall. Assuming that this collision is the closest collision found, we move the entity along the normalized direction vector, slightly less than the actual distance to the collision. And if the entity was trying to travel further than where the collision occurred, we can project the endpoint onto the wall's normal and make the entity slide. That's a big oversimplification, but that's the basics of my collision system. I'm quite sure this is pretty standard. So, what was going wrong? Well, it turns out that a normalized direction vector I've mentioned wasn't actually being initialized. I somehow forgot to do that, and because of this, the entity only moved when there wasn't a collision, or, weirdly enough, when there was a slide, which is stupid, but it turns out when you're not moving very fast and you've got a very high frame rate, this happens a lot. So when I debugged my collision code, I capped the frame rate between 10 to 15 frames per second, and it felt like it took forever to get all the bugs out and get it working properly. But in reality, it was 4 days. 4 very, very long days. Thankfully, after this, the collision code seemed to be working without obvious fault. So that was good, as long as it was running under 60 frames per second. Once I put it back onto uncapped, it broke again. This was frustrating, but I concluded it came down to floating point precision and rounding upwards. Unfortunately, I couldn't locate the specific instance where this very low floating point number was being passed through. So, to avoid rewriting the collision engine or going through it with a fine-tooth comb, I lazily hacked around it. I've kept the game capped at 60 frames per second, which, it's fine. It's a bit of a cop-out. But since I've played a lot of games made by professionals where there's a lot of clipping issues, collision fails, people fall through floors, I decided not to be so hard on myself this time, since it is my first attempt of writing a full 3D collision system for a complete game. So I'm going to allow this compromise for now, for this project. Hopefully next time I'll write a better collision system. Hopefully. At this point, you're probably wondering, why on earth did you need a full 3D collision system for a game that's 2.5D? Well, I didn't, really. I could have simplified it a lot more, but I'd never written a complete 3D collision system, so, I wanted to give it a go, because learning's cool. And so I guess I'm pretty cool. And that's pretty much it. That's what I've been up to. I've only got maybe 1 or 2 more things before the engine's complete. Then it's just putting all the content together, making a game. So, if you've managed to sit there and get through all of this, thank you very much. It really does mean a lot to me. And feel free to leave a comment. And hopefully I'll make another update which isn't months and months apart from this one. See ya.